All right, I want to welcome all of you to the Honors Algebra 2 video Chapter 3 review. We've had some technical difficulties here, so if you're watching this, hopefully will be okay here. And let's get going then. First part of the test will be on factoring. Factoring out the greatest common factor. So 5x cubed is the greatest common factor. Dividing out 5x cubed, you're left with x minus 3. Notice it's not asking you to solve, it is merely asking you to factor. The next one is the difference of squares, 10x times 10x minus 3 and plus 3. So values, 10x times 10x, 9 gives 3 and 3, 1 plus and 1 minus, difference of squares. Next one is a trinomial. This is the page that usually people struggle on a little bit. 18, so I need factors of 18 that would add up to 11. 9 and 2, so x plus 9 and x plus 2. Notice it is not asking you to solve again, so you would leave your answer as a factored. Next one, outside two numbers together, is negative 63. So I need factors of negative 63 that would add up to 2, 9, and 7. Now, what's different about something with a lead coefficient, you are now going to set the outer as one of those two, so positive 9, meaning a factor of 3 and a factor of 21, getting you a positive 9. And then next, all you have to do now is fill in the blank. So 3x times 1x is 3x squared, and 3 times negative 7. Again, not asking you to solve, merely asking you to factor. The next one is factor by grouping. Take out the greatest common factor in the first two terms. Take out the greatest common factor in the next two terms and group the coefficients in front and leave what's the same alone. Now, I will accept this answer tomorrow or on the test, but there is actually, this can have a GCF. So if you wanted to factor completely, this is technically the correct answer. Solve by graphing. Now, the vertex on this one is not very nice. First, I'm going to make it equal 0. Then you're talking about graphing y equals x squared minus 3x minus 4. It is in standard form, so negative b over 2a, which actually gets you a 3/2. Plugging 3/2 back in, you will actually get 6.25 over 25 fourths. So 1.5, 6.25, 2, 3, 5, 6, right here. Now, graphing that's going to be a little bit more complicated. There's not going to be a vertex quite that rough on the test, but it actually crosses at negative 1, 2, 3, 4, and positive 4. So here is the parabola. The x-intercept at negative 1, 0, so that means x equals negative 1. And then the y-intercept at positive 4. Sorry. The other x-intercept also being at x equals positive 4. Sorry about the pause there. Next one, using square root properties, subtracting 11 from both sides, dividing by negative 6, and taking the square root. Remember, anytime you take the square root of both sides, you will always get a plus or minus answer. Do not forget to have the plus or minus answer when doing the question. Next one, we have a binomial. We're still going to take the square root of both sides. Still going to get a plus or minus answer. But the square root of 18 can be simplified as being 3 square roots of 2. Now, to finish this then, subtract 2 from both sides to solve 3 square roots of 2. And that is solving using the square root property. Solve by factoring. So again, we got to go back and understand our factoring skills. Multiply the outside two numbers together. Factors of negative 24 that would add up to positive 5. We'll then set the outside as one of those two values. So I'm going to set it as positive 8 using a factor of 4 and a factor of 6. to get my positive 8, and then it's fill in the blank. 4x times 1x gets me 4x squared. Negative 3 times 2 gets me negative 6. Now it is asking me to solve. So now I set the parentheses equal to 0 and solve both of those. So x equals negative 2 and x equals 3/4 are my two solutions. Another solve by factoring. I don't like the fact that we have a negative in front of my x squared, so I'm actually going to move everything to the other side of the equation. When I'm factoring, multiply the outside two numbers together, I get positive 14 that I want to add up to negative 9. Negative 2 and negative 7 are factors of 14, factors of 14 that would add up to negative 9. Again, on your test, you want to show that you understand how to factor, and then you want to show how you understand how to solve. X minus 7 equals 0. X minus 2 equals 0. Now we're going to simplify radicals. Here's where we're talking about complex numbers, or I. So anytime you have a negative square root, you're talking about I. Now you also have to break down or simplify the square root of 72. It has a pair of 3's and a pair of 2's. So anytime you have more than one pair, you multiply them together. Anytime you have more than one single, you would also multiply them together. Since I only have one single, it's 6i squared root of 2. Next one, again, I'm just going to simplify the square root of 12 first. So 2i squared root of 3. Then multiply it by 5. Now for some questions your calculator can help you with if you put it in imaginary mode. If you are subtracting, you take the 2 minus the 7 and you get negative 5. So again, 2 minus 7. Now you're going to take negative 4i minus 3i and combine like terms. Next one, you're going to FOIL first, outer, inner, and last. Now let's talk about I squared. I squared is equal to negative 1. So this is negative 30 times negative 1, which is positive 30. And now you add the like terms, 30 and 6, negative 18i, and positive 10i. This will be missed by a lot of people on the test tomorrow. Anytime you're taking something, a binomial, and squaring it, you need to FOIL it. First, outer, inner, and last. I squared ends up being negative 1 again. So this is negative 49, and I combine like terms. Negative 45 plus 28i. Completing the square. This is one of the most missed questions again on this test. So let's go over completing the square. You'll take the x squared and the x term, do half of 6, which is positive 3, add and square. This side makes your completed square, and this side ends up being 25. Now, if you go back to number 3 and you looked at that one, you would see that this is what we would solve by square root property. Take the square root of both sides. Take the square root of both sides, subtract 3. So I have negative 3 plus or minus 5. Now, because that ends up being rational, split that into two answers. So negative 3 plus 5 and negative 3 minus 5. Again, get the x squared and the x term, the constant, on the other side. Half of 8 would be 4. Always add and square. This side makes your completed square. And the other side, negative 8 plus 16 is positive 8. Take the square root of both sides, which gets you a plus or minus answer. Square root of 8 does simplify to 2 square roots of 2. Subtracting 4 from both sides, I get negative 4 plus and minus 2 square roots of 2. Next, we're going to use what we learned about completing the square to now put something in vertex form. You're transferring from standard form into vertex form. So now x squared minus 8x, I want to do half of 8, which is positive 4 squared, added to both sides. X minus 4, that's actually a common mistake there. The sign for the b term is actually the sign for your completed square. Subtract the constant to put it in vertex form. Now, that makes the vertex at positive 4. -5. Let's talk a little bit about this, especially those of you with graphing calculators. If you write something in standard form and then write something in vertex form, it actually should be the same parabola. So if you have time on the test, make sure you go from standard form to vertex form and check your answers using a graphing calculator. So the next one has a coefficient, and this adds a degree of difficulty here. I need to take the -2 out of both x terms. So if I divide the first x term by -2, I get x squared. If I divide the second x term, I get positive 6x. Now, complete the square inside, so half of 6 would be 3 squared. On the other side, now make sure that you multiply 3 squared times -2, which would be -18. That makes your completed square. Add the constant, and that makes a vertex at -3, +7. Make sure you understand, if it's in standard form or if it's in vertex form, it still should be the same parabola. Last one, I need to take the 1/3 out of the x terms. So if I divide the first term by 1/3, I get just x squared. If I divide the 4 by 1/3, I actually get 12x. Half of 12 is positive 6 squared. But on the other side, you have to multiply it times 1/3 when adding it to the other side. That completes my square. Add, or in this case, subtract the coefficient over to put it in vertex form, and you get -6, +1 as your vertex. Quadratic formula, you need to memorize the quadratic formula. -b plus or minus the square root b squared minus 4ac all over 2a. So in this particular, -2 plus or minus the square root b squared minus 4 times a times c all over 2a. Now, the hard part about this is always known as the discriminant. It's the value under the radical. In this case, you get 32. 2 squared minus 4 times 1 times -7. Off to the side now. And on your test, there'll be a blank. The discriminant is 32, which means there's 2 real solutions. And now I need to finish this question. The square root of 32 can be simplified as being 4 square roots of 2. And now everything is divisible by 2. It's not just one term, it's all terms. So the first one's divisible by 2, the second one's divisible by 2, and that is your answer. We'll try it again. Again, if you are doing the quadratic formula, it must equal 0. -b plus or minus the square root b squared minus 4ac all over 2a. So I get -6 plus and minus. Again, we have to find the discriminant inside there. You get -4 as your discriminant. 36 minus 4 times 2 times 5. That means -4 is the discriminant. And that means there's 2 imaginary solutions. If it ends up being a discriminant of 0, which we don't have an example of that, but if it ends up being a discriminant of 0, you would say 1 real. Keep going here. -6 plus or minus 2i over 4. And then all of them are divisible by 2. So -3 plus or minus I all over 2 is the correct solutions. All right, we got a word problem. Do not be alarmed. The height h of t in feet of an object t seconds after it's propelled straight up into the ground has the initial velocity of 60 feet per second is modeled by this equation. At what times of the object is the height 56 feet? Again, they are giving you the height and they want to know the time. So 56 equals -16t squared plus 60t. Using my knowledge about quadratics, I'm going to set this equal to 0. And I want to go ahead and use the quadratic formula. So negative b plus and minus the square root, b squared minus 4ac all over 2a. Again, the hard part about this is finding the discriminant. You end up getting 16 under the square root. So this breaks up now into negative 60 plus and minus 4 over negative 32. And so again, solving this, you get two answers then, negative 60 plus 4 over negative 32, and negative 60 minus 4 divided by negative 32. Running out of space here, but you get 1.75 as one answer and 2 as the other. Now, why is there two answers? I want to go through that just quickly here. If you had a projectile, or propelled up into the ground, up above the ground, it would hit in two locations, one on the ascent as it's going up, and one on the descent as it's going down. Solving a nonlinear system now. This one can be done by elimination. These two would cancel. So x squared plus 2x equals 3. Now you have a quadratic that you can factor. Positive 3 and negative 1 are factors of negative 3 that add up to positive 2. Solving, setting the parentheses, equal to 0. Now I'm going to go back and plug these two answers into the line. It's always best to plug it into the line. So if I plug negative 3 in for x in the bottom equation there, I end up getting positive 7. If I plug 1 back into the bottom equation there, I get 3. So again, the top one is actually a parabola and the bottom one is a line. And so you'll have a parabola and a line that cross in two locations. Next one, this one actually is a circle with a line. Substitution allows me to take the bottom equation and substitute it in for y into the top equation. A lot of people are going to get this wrong because they're not going to FOIL. Same thing we talked about earlier. If you have a binomial being squared, you must FOIL. So x squared plus 6x plus 9 equals 29. Putting all the values on the same side. Now, you have options at this particular moment here. It's not asking me to solve this in any particular way. So if you're a quadratic formula kind of person, A is 2, B is 6, C is negative 20, you can go from there. I'm more of a factoring person, so I'm going to simplify this and divide everything through by 2. Factors, and I'm running out of space here, but factors of negative 10 that would get me 3 would be positive 5 and negative 2. Setting the parentheses equal to 0, I get 2, negative 5. Going back up now into the line, if I put negative 5 in for x, I get negative 5 plus 3, which is negative 2. If I put 2 in for x, 2 plus 3 is positive 5. Next one, solving algebraically. Make sure that it equals 0 or is greater than or equal to 0 in this case. This one is factorable. Factors of negative 40 that add up to factors of negative 40. So let me do that again. Would be positive 8 and negative 5. Setting the parentheses equal to 0, I get negative 8 as a solution and positive 5 as a solution. Now, this is an inequality, so now you're talking about critical values on the number line. Negative 8 and positive 5. It's an equal to, so you're talking about closed circles. Now, how do I decide where this is going to be shaded? Is it going to be shaded on the outside or is it going to be shaded on the inside? Again, test one value, such as 0. 0 is located in between the two values. If I plug that in, it does not work. Therefore, it must work on the outside. Now, that is not good enough. You must write your answer as an inequality. So x is less than or equal to negative 8 or x is greater than or equal to 5 is the correct solutions. I don't like the fact that there's a negative, so I'm going to go ahead and multiply everything through by negative 1. That does change the inequality symbol, because anytime you're multiplying both sides of an inequality by a negative, this is not factorable. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 4 plus and minus the square root. Again, the discriminant is always the more complicated part of this. You end up getting positive 28. Positive 28 does simplify into 2 square roots of 7. And all of those are divisible by 2. So there's my critical values that I'm going to put on a number line now. Putting this up here at the top, you're talking about negative 2 minus the square root of 7 over 3. And you're talking about negative 2 plus the square root of 7 over 3. Testing a value like 0, open circles as well. Testing a value like 0, it does not work again. So now I'm talking about on the outside again. And how I would write my solution then is x is greater than negative 2 plus the square root of 7 over 3, or x is less than negative 2 minus the square root of 7 over 3. Graphing a quadratic inequality, I first need to come up with what the vertex is. So negative 5, negative 7. Sorry for the pause there. Negative 5, negative 7. Then using my counting principle, 1 over 1 up 2 over 2 up 8. For those of you that don't remember, it's over 1a and 4a. It is dashed, as I went too quickly there. Dashed. Why is it dashed? Because there is only a less than symbol, and then shading. I would decide if I was going to shade outside or inside the parabola. You can test a point like 0, 0. It actually does work in this particular question, and so therefore you would shade on the outside or under the parabola. Next time, this one is in standard form, so I need negative b over 2a to find my vertex. So I end up getting a vertex at 1, 8. It is a downward parabola, so over 1, down 2, over 2, down 8 for A. It's a solid parabola. Shading now, it's again shaded greater than. If I tested a point, all the points on the outside would work, and all the points on the inside would not work. System, I have 2 that I now have to graph, and so those of you that like using color, this would be an opportunity for you to do one in one color and one in another. Negative b over 2a, so I end up with 2. Plugging 2 back in there, I end up getting 4. So the point 2, 4 is the vertex. It goes upward. So we're talking about over 1, 1a, over 2, 4a. It is dashed. And I'm going to hold off on shading, but it's shaded on the outside or below the parabola. I'm going to do the other one now in blue. Negative b over 2a. I end up getting positive 2. Plugging positive 2 back in there, I get 6. So at 2, 6 is the correct over 1, down, over 2, down 1, 2, 3, 4. It is dashed, or excuse me, this one is solid. Now, some of you are going to look at this and say, well, it's going to have to be shaded in between. It's actually not. It's actually shaded on the outside of both of these. So it's shaded above the blue line and below the red. And so therefore you basically are shading outside on both of them. If you pick any point out here, it should work in both equations. If you have any, that actually concludes what we got going today. If you have any questions, make sure you ask myself or Mr. Bone, and we'll be happy to help you out. And good luck on your test tomorrow.